Night Clouds, presented by Science at NASA. A series of upcoming rocket launches will create glowing white nighttime clouds visible from the eastern seaboard of the United States. June 20th, 2003. One night soon, people on the eastern seaboard of the United States might see some strange clouds in the sky, milky white, glowing, and twisting in the wind. The clouds will be man-made, created by scientists to study Earth's ionosphere, a layer of our atmosphere near the edge of space. 3 rockets launched from the NASA Wallops Flight Facility on Wallops Island, Virginia, will release a chemical called Trimethylaluminium, or TMA, into the air 90 to 175 kilometers above the Atlantic Ocean. TMA burns spontaneously in the presence of oxygen. The harmless byproducts of this glowing reaction will be visible from coastal Virginia, North Carolina, Maryland, New Jersey, Washington, D.C., and possibly parts of lower New York and Pennsylvania. The launches will take place between 9:30 p.m. and 5 a.m. on a night yet to be decided between June 23rd and July 10th. The time and date depends in part on clear skies at 2 of 3 special camera sites located along the Virginia and North Carolina coasts. Members of the public can keep track of the mission by calling the NASA Wallops Flight Facility Launch Status Line at 757-824-2050. A pre-recorded message will be promptly updated when launches begin. NASA will also have a website with text updates and live video of the launches during the mission at http://www.wff.nasa.gov/webcast. The clouds will allow scientists to monitor winds in the ionosphere, explains Gregory Earle from the University of Texas in Dallas, the lead researcher for the project. They will act as a tracer and allow us to view the winds at various altitudes over a period of time. This is important because of space weather. The ionosphere is a critical link in the chain of Sun-Earth interactions. Solar flares and radiation from sunspots break apart molecules and ionize atoms in Earth's upper atmosphere. This is how the ionosphere is formed. The ionosphere, in turn, affects such things as radio communications and global positioning system reception on Earth. The data gathered from this project will aid in our understanding of the relationship between the winds and ionospheric activity, says Earle. This research may one day lead to better forecasting of space weather effects on satellites, communications, and power systems. There will be 4 rockets launched, but only 3 will release TMA, the first, second, and 4th rockets. The 3rd rocket carries only scientific instruments. The TMA will be released over the Atlantic Ocean at altitudes from 56 miles to 109 miles. The clouds will take about 4 to 5 minutes to form after the TMA release and remain visible for approximately 20 minutes. There will be about 90 minutes between the launch of the 1st, 2nd, and 3rd rockets. The 3rd and 4th rockets will be launched about 10 minutes apart. The actual period between launches will be decided in real time as the mission unfolds. NASA has used TMA for decades as part of rocket studies from sites worldwide to study the near-space environment. TMA burns slowly and produces visible light that can be tracked visually and with special camera equipment. The products of the reaction when TMA is exposed to air or water are aluminum oxide, carbon dioxide, and water. Aluminum oxides are commonly used to combat heartburn and to purify drinking water. TMA poses no threat to the public during preparation on the ground or during release in Earth's atmosphere. This project is a NASA and multi-university effort. In addition to the University of Texas, students and personnel from Clemson University and Utah State University are participating in the mission. This story is based on a NASA headquarters press release. It's presented by Science at NASA. To find more Science at NASA stories on the Internet, please visit science.nasa.gov.
Everybody, the sun, it's the source of all life, and it could mean the end of life as we know it. NASA did a study, and its findings are now out. We're not talking about global warming, a brand new government study on the very real destructive threat of solar storms. Check it out, the surface of the sun, a roiling mass of plasma and charged high energy particles. As we move to the launch pad, we can show exactly what we mean, escaping the surface of the sun and traveling through space to areas down here on Earth. Now, this giant fireball, if that ball hit the Earth and its magnetic shield, it would be devastating. I want to show you New York City at night. Times Square, drove through here at 8 o'clock last night. Streets are empty, but the electric power grid would be wiped out by the current. Lights and computers, transportation, hospitals, all would go down. The study warns it would be a disaster, far worse than anything we have seen before. The menace of these sunstorms poses a bigger threat to more high-tech and advanced countries like the U.S. Everything from our sewage systems to our Wall Street banks operate with our power grid. And a game-changing solar storm that could hit at any time. So how worried should we be? Sounds like we should be. Michio Kaku is an astrophysicist and author of The Physics of the Impossible. Sir, good morning to you. Welcome back here.
Glad to be on your show.
Now, what I'm reading here scares me to death. Should I be that way?
That's right. We're talking about a potential Katrina from outer space. Katrina caused about $100 billion in property damage. And unless we begin to make efforts now to reinforce our satellites and power grid, we could have something maybe 10 times bigger than Katrina, because we're talking about the loss of all electricity and all satellite activity. We'd be thrown 100 years back into the past.
Michio, has this happened before?
In 1859, we had a humongous storm that wiped out telegraph poles, and we tried to then estimate what kind of power could do that. And we now realize that we are very young in the space age. If something like the 1859 storm hit again, it would literally paralyze all the United States, not just for a day or an hour, but for months to years. Transformers would short circuit and burn out. Satellites would be fried to a crisp. And the sun, however, has these storms every 11 years. Every 11 years, the magnetic field flips. But in 2012, we do expect perhaps another big one.
Well, we have never before in our history, in human history for that matter, relied so much on technology as we do today. And that's part of what they found in the study, because we rely so much on our ability to communicate through our computers that they would all go down, which would handicap not just New York, but really the eastern half of the United States. That's what the study finds, which would be far worse than the blackout of New York from 4 years ago, Michio.
That's right. Those blackouts only last for a few hours to a day. But if you start to short-circuit all the transformers and blow out the satellites and fry the communications grid, then you're talking about knocking out the United States for months before we can get enough rescue crews and repairmen to handle not just one city, but hundreds of cities around the United States.
You know, Michio, sometimes you come on here and you sound like the doctor of doom and gloom. Does something like this keep you up at night?
It does, and I think with Katrina, you know, engineers knew that Katrina could happen, but they did nothing because they said that it's not going to happen while I'm around. Well, now we learned the lesson. You have to prepare for things, especially when you know that at some point it's inevitable that we're going to have another big one, like we had back in 1859, except this time we're totally dependent on electricity.
Michio, thank you. Hope to see you in person next time. We'll take you on the phone if we can. Michio Kaku, thank you for your time today. 1859. I mean, we're going back 150 years on that, Megan. Now he's wondering about 2012. Watch for this story.